Hello. That was a false start. Don't worry, though. The editors are excellent.
You get one of those, I think.
Yeah, but this will be in it because they don't ever edit in my favor. That's why I'm trying to flatter them. Okay.
Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode cloud servers. Head to linode.com/changelog. Linode makes cloud computing simple, affordable, and accessible. Whether you're working on a personal project or managing your enterprise's infrastructure, Linode has the pricing, support, and scale you need to take your ideas to the next level. We trust Linode because they keep it fast and they keep it simple. Check them out at linode.com/changelog.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. Changelog++ has officially launched, and it's the best way for you to directly support Go Time. Join today to make the ads disappear, get closer to the metal, and help sustain production of Go Time into the future. Learn more at changelog.com/++. All right, we've got a great show for you today. Let's do some Q&A, shall we? Here we go.
Hello and welcome to Go Time. I'm Matt Riot. Today we're doing a very special live Q&A episode. Because yesterday, right, John Calhoun, who's with us today. Hello, John.
Hey, Matt.
Yesterday, John, you posted on Reddit asking for people's questions, didn't you?
Yes, I did.
And what do you think? Quite a good response, isn't it?
Lots of questions.
Lots of very good ones. And we're going to do our best to answer them. But don't worry, we're not doing it on our own. Joining us today, Peter Bergen and Roberto Clappis. Hello.
Oh, yeah.
Hello.
Welcome. Peter, how long have you been doing Go?
I guess since the beginning, depending on what doing Go means precisely. I remember the day it came out, it was like, I had been at that point working a lot in C++ and basically getting frustrated with how difficult it was to do concurrency stuff correctly. So it was like very timely and appropriate. And I remember like building Quicksort or something on day one and being very frustrated and confused as to why it wasn't fast. And that was my start.
And what about you, Roberto? How long have you been at it?
5 years.
And what made you get into it?
So basically, I was using a piece of software that was extremely slow and took way too many resources, in my opinion. So I just decided, let's rewrite it in Go and see how it goes. And it was much better.
That's a very interesting thing. We've got some questions that relate to that. And I think that's kind of an interesting clue. So that'll be interesting. How about you, John? How long have you been doing Go?
That's a good question.
It's probably you did not expect it.
It's probably
so just ask those.
I've never had anybody ask me that one. It's the first. It was probably like 2012, 2013.
Yeah.
That one stemmed from, I was working on a project where we had to talk with a bunch of APIs concurrently, and it was written in Ruby. So it was kind of just annoying because our, Ruby handles like one request for, server you have up, if you're using Ruby on Rails at least. And while we could do all the different requests, like in threads and wait for the response, it was annoying that our server would basically sit there doing nothing while it waited for some APIs to respond. And I was like, if we could actually have a server that you can handle multiple requests at once, there's no real reason why this one can't do it. It just wasn't set up to do it at the time.
Mm-hmm. Yeah. See, that's another thing. You get a few things that it does kind of out of the box that are very attractive. And actually, one of our first questions from the Reddit feed is from DLibian. And DLibian asks, what kinds of projects are best for learning Go? Are there any, for people that really want to start to learn Go, are there any types of projects that are more suited and more suitable? Or can they just sort of pick any problem and go after it? What do we think?
I think generally speaking, diving in is more important than getting the perfect project. For me, I always like doing things on my local file system, like opening up files, appending to them, maybe, just simple stuff like that I can actually go look at a file and verify that it worked as I expected. Not having to worry about servers and that sort of stuff that doesn't necessarily make it super complicated in Go, but it's harder to verify everything. So that's where I tend to start, but I think each person's going to be different.
I totally agree with this impulse, like simple and a domain you're familiar with. You don't want to be like learning both a new problem domain and the language at the same time, right? You just pick the thing to spend your energy on. So ideally something you've written before and won't take you like a month. But I've heard Go described as like a DSL for writing network servers, which resonates with me, all else equal. A simple thing that deals in packets and requests and stuff, I think is probably the type of project that's going to expose you to the most and widest variety of parts of the language, I think.
Yeah, for me, one of the first things that I wrote was crawler, a web crawler. And I think that in general, Go shines best in tooling. When you need to do something, I don't know, a repetitive task that you don't want to do by hand. So you go like automate it with Go. No UI, no nothing. You just write a console program and you run it. And I think that's in general a good thing to start with.
Yeah, that has the nice benefit of also being able to solve a real problem that you have. And I think that's always an advantage. If you can, when you're learning something new, if you can solve a real problem with it, then you're in a much better position, aren't you, to kind of focus your learning. You kind of you have to learn the bits you need for this thing. So it's quite a nice way to cut out a lot of what you could be learning and really focus on something. And then at the end of it, hopefully you've got something useful. I know teams that have done that as a way of introducing Go into the team. They've sort of found a little problem that they've all got, and somebody's just taken it upon themselves to solve it. And usually it is a tool. It's exactly that, some command line thing, something that the developers are using. So, it's not going to go straight into production or anything like that. It's something that you can have a slower introduction to. I think that is kind of a good strategy. And then, I echo what you say about the domain as well.
One thing that I found really funny is that in a company a friend of mine works in, they started using Go to generate code for Java. So basically, to generate some repetitive code, they found that the text template package in Go was working pretty well for them. So they just generated some code with Go in another language because that was just an option. And they started using Go with that, which I found pretty funny because many people say that Go has the downside of having to generate code if you need to write generic kind of algorithms. And that was kind of a funny experience to have.
I also wouldn't expect that, Go's templating language, which I think we could all agree is maybe not the best in the world, would be like the best default choice for something like this.
I wonder if it had to do with the fact that it's built into the standard library, and in a lot of other languages that I'm aware of, at least, it's not really built into the standard library.
Yeah, that and the fact that you could very easily expose language functions that you wrote in the language to the templating language. So it was very easy for them to just write most of the logic in Go and just expose the function that they needed to the template.
Mm. Yeah, another question that was asked by 9volt is why should people try Go? So some people are kind of skeptical, and I understand this. There's so many new things. You don't want to have this shiny object syndrome where you're just chasing everything and you never really get good at anything. But so some people therefore become automatically skeptical and hold back from learning a language. And this is the case for this particular questioner. And they asked, is there a kind of convincing sales pitch to convince people to try something with Go? And by the way, they are putting together like a summer like sound bites thing. So if your answers could be awesome little sound bites, then that'd be great. And there's more chance to get on the little sound bites thing.
If we can just drive all human conversation more towards the Twitter model and away from reason discourse. Yeah, I know, understood.
Yeah, because it's what works, isn't it?
Yeah, it's clearly, right? And we're all building our personal brands here. So this is also, it's all part of the big picture. Yeah.
By the way, that's a great example. That's going in.
Is Pace pivoting to like
another take?
No, it's perfect.
Some gaps. Okay, great.
I'm waiting for Pace to pivot into like Zoom plugins that count your characters while you're talking.
Whoa. Wow. Let's make that never a reality, please.
Too complicated. So this is an interesting question because there was a period of time, I think, where it wasn't clear that Go was going to stick around, and you did need to make the pitch to get people interested, right? It's like, well, I understand you're not convinced, but here's some use cases and here's some things that it has worked at, and here's some success stories. But I think we're past that point, right? I think Go has like carved out a reasonably well-defined area context in which it is like useful. And I think if you look even a little bit, you'll find the success stories. And if you look, often if you don't look at all, you'll find the things that people dislike about it. And you can get a pretty good idea of like what's good and what's bad, and if it's appropriate to your use case. So I think we're at a point, and this is like my personal opinion, where like, if you're not convinced, then fine. Like there's nothing wrong with that. Like if you need someone to pitch the language to you, I don't know, like take some of your short life on this earth and spend it in a way that brings you more joy. Like it's fine to like say Go isn't something that's going to be useful for me right now, and move on to something else, in my opinion.
Absolutely brutal, as expected. Thank you, Peter. Roberto.
My answer is a little bit less brutal, which is I think people should learn Go because it makes their code better, even if they decide not to use Go anymore afterwards.
So how does it do that?
I found out that after years of using Go, my code in other languages, which I still use, is better because I try to keep the line of sight, stuff indented to the left, code simple, stick to the native types, do not create unnecessary types where they're not needed. I would also say that the lack of generics so far forced me into trying to write the simplest code and code that was closer to the data that I was touching instead of just being generic and maybe being efficient. And now I found that even when I write TypeScript, which is the other language that I use the most, and Java, my code is more readable.
Yeah, Go biases you away from abstractions in general. And I think this impulse is probably extremely good in many different languages. Right?
Yeah, I agree.
Or like at least motion in that direction.
I would generally agree with Peter that if you haven't been exposed to a scenario where you've already considered Go, there's probably not much at this point that's going to sell you. And I think trying to make the sales pitch is just not going to resonate. The only thing that I would probably add to like what Roberto added and everything is that the community in Go is also something that I think other languages should sort of look at and get an example of, like, at least it's one of the better ones in my experience. So like getting a feel for what it could be and making sure they set the bar at the right level versus just sort of accepting a toxic community.
Mm-hmm. Yeah, I think that's a great point. I think those are all great points. For me, I'd say that in particular, if you're building web servers, web services, JSON APIs, those kinds of things, Go does a good job with those kinds of things. You get a lot out of the box for free. For example, each HTTP request runs in its own Go routine because of the standard library, the way that works. So kind of automatically you get a level of quite safe concurrency to operate in. And you may get that also with other languages. Another point is that there shouldn't be a kind of language war thing going on as well, which just seems to very naturally happen quite a lot. People want to know, why is Go the answer? And really, we don't have the question. So it depends on what that question is. Some languages are great at different things. And I think that's probably something that is worth avoiding in yourself early. I know that I used to think more like that. And, a more relaxed sort of open-minded attitude, I think that helps. Because like you say, there's things in other languages which we can learn from as well. Pure functions is one example that Rust makes extensive use of. In fact, it's the only way you can do it, I think. And you can then write pure functions in Go and take some of those lessons if you want to. And so that sort of stuff's nice. But yeah, anything that involves web and APIs, and I think tooling is another great area. When you've got a task, something repetitive you want to run through, Go is nice. It's not just a good way to learn, but it also does quite a good job, even if you haven't written it perfectly. I think that's quite cool.
I just wanted to extend that a tiny bit because you touched on something that I've seen over and over in the like newbies Gophers Slack. I think it's a little bit like what Go is or isn't suited for. And you said it's really good for like writing web servers, right? And I totally agree. But I think something a lot of people don't understand is that the Go model of what a web server or HTTP request is substantially different from a lot of other languages. In Go, the central model is the request itself and the path it takes through the handler stack in the same way the execution path takes through a call stack, right? So this is what Go wants you to think about in terms of this like relatively mechanical bit of the thing. And in many other languages, the model is completely different. It's like the model view controller idea, where it's like a route being matched to a controller that that interfaces with like domain models in a repository. And like a lot of people who are used to this latter one come to Go and find it very like low level and like unproductive. And I think for them, it actually probably is. So to go back to the question, it's like, what is a bad fit for? If you want to build like in sort of the consultancy style, sort of like high throughput, very rapidly produced kind of cruddy web services, I think Go is probably not a great fit because that's not the model that it uses to talk about HTTP. I think this is like a really interesting thing that comes up over and over again. I don't know, maybe that's just me.
I would say that to address that, some people wrote frameworks. It's like, I know that there are some frameworks that when you use them, they don't feel like Go, but they allow you to write Go in other parts of the code, and the entire HTTP kind of CRUD stack or MVC stack is handled by the framework. But I would agree with you. And there are other things in which Go is not good for. I would say that, for example, it happens all the time on Twitter when people discuss that some things should be made in Rust or in Go or in C or stuff like that. And I would say that most of the time, one of the two is a better choice. It's like, if you need to write firmware for an embedded device that has a very limited amount of memory, yes, you could use Tamago or TinyGo, which are two perfect options. But I would just say that maybe that is not what you're looking for. Like if you have to write a real-time application, Go still has a GC. You can write GC-free Go. It's not pleasant. So just use the right tool for the job.
So a follow-up question sort of to this is, Best Form had asked, do you follow other programming languages? And like, do you compare their design choices and the ones they're making with what Go is making as design choices? And if so, I guess, which ones are you following? Like, how has that sort of influenced you?
I'm following TypeScript, JavaScript, Rust, and Java, mostly. And I have to say, there are some things that I really like about those languages. There are some things that I have to use from those languages. I try not to do the comparison. It's like, I know what the languages are for. Sometimes I carry over some concepts, but it doesn't influence me too much to know other languages or to follow other languages.
Do you find that do you think about them in terms of their like founding principles or like theories, or like at a sort of more abstract level, and sort of compare that with Go? I find this often like quite interesting, although maybe ultimately non-productive. I don't know.
I've never think of it in these regards. I just use them and I try to click in the mindset. It's like when I speak English or when I speak Italian, it's not like I try to think in the other language and see how I would put the sentence in the other language. I just click into it and try to think in it. I've tried to build UIs with Go. I still prefer the TypeScript approach on some things. And I've tried to build stuff with Rust. And at one point I just gave up. I said, okay, no, I'm just going to use Go. It doesn't work for me. But most of the time when I start with the language, I just stay in that mindset. So
a follow-up, I guess, to that, since you're switching mindsets, like one of the big things in Go is you write readable code. Do you find in other languages that you don't prioritize that as much just because that's kind of the norm in the language?
Yes. I find Java unreadable. It's a big limit for me because Java uses very long lines, and most of the time you have a auto formatter that will split the line automatically. So I'm used that in Go, one line means one thing, and in Java sometimes you have like 24 lines that are saying a single statement. That kills me.
What I find super interesting is that even what constitutes readable is like completely different from ecosystem to ecosystem, right? Or person to person also. And so this like subjective definition difference is also like super interesting to me, because I think for a lot of people, for example, in maybe the Rust sphere, I don't know, readable is like what is somewhat terse and compact and conveys like the most semantic information, not the most of objectively the most, but like a lot of semantic information in a few, I don't know, characters. But for Go, like simplicity has a completely different meaning, right? What we mean when we say it is totally something else.
I think Rust is probably the one I see this the most in, because people will show me, I think it's maybes. and they'll show me code that like does something, like they'll compare it to error handling in Go. And they'll say, look, looking at that if error is not equal nil is like distracting. And then they'll show me the example in Rust. And I'm like, I don't know Rust, so I know that's my issue here, but I don't know what that code is doing. Like, it just is not clear to me. And I'm like, so for me, at least in Go sense, readability is somebody who basically is just a junior programmer could look at this and probably get a pretty good idea of what it's doing. But in Rust, I think you're right. They're viewing it differently. What they consider readable is different.
And like this error handling thing, I'll just quickly, is like such a great example because in Go, error handling is explicit as part of like the philosophy, right? Go considers error handling to be programming, right? And in a lot of other languages, it's just not modeled that way. And that has like ramifications.
Right, but I also think that it matters how much of your brain you're willing to dedicate to the language instead of the code that you're writing, instead of logic that you're writing, and how much you're willing to dedicate to the actual problem that you're trying to solve. And sometimes Go might exceed on the other side, but I like that when I read Go and when I write Go, my brain doesn't invest any energy in how do I do this in Go? I know how to do this in Go, I just do it, which is not true in many other cases. And so I like that simplicity, and I like that I don't have to focus to write Go on Go, but I can focus on something else.
What's up, Gophers? Are you looking for a way to instantly debug and troubleshoot your applications and services running in production on Kubernetes? That's a mouthful. Well, Pixie gives you a magical API to get instant debug data. And the best part is this doesn't involve changing code. There are no manual UIs, and all this lives inside Kubernetes. Pixie is an API which lives inside your platform, harvests all of your data that you need, and exposes a bunch of interfaces that you can ping to get data you need. Pixie is essentially like a decentralized Splunk. It's a programmable edge intelligence platform which captures metrics, traces, logs, and events without any code changes. And the team behind Pixie is working hard to bring it to market for broad use by the end of 2020, but I'm here to tell you how you can get your hands on the beta today. Links are in the show notes, so check them out so you can click through to the beta and their Slack community. Once again, links from the show notes, check them out, and look forward to Pixie Day coming soon.
There's some interesting questions actually around some of the specifics of how we actually do things as well. There's a lot on structuring, which I think we'll come to later, but there's one that I quite like here, which we can discuss, and we may have differing opinions. To constructor or not to constructor? Some languages make heavy use. In fact, sometimes they're compulsory. In order to create a class, you have a constructor. In Go, you don't really have classes, but you can still kind of have this idea of constructors where you just sort of have a function, usually prefixed with new, to create something, and then it returns the thing and maybe sometimes an error if there's some work to do to get that thing. How do we feel about constructors?
I even have a follow-up question. How do we feel about builders? Like once we decide on constructors, what about builders?
Okay, let's do constructors then first, and we'll do builders after.
I can start by saying that when I started writing Go, I wrote a constructor for everything. And I think part of that stemmed from my history is Ruby and Java. And Java, Go, like in some ways just sort of felt a little bit more like Java because it was typed and some of that stuff. So I think I just jumped into that mindset of I need to write these. And then I don't know when, but at some point I kind of realized that a lot of these constructors were not useful. You know, I didn't need them at all. So I started sort of taking a step back and asking myself, do I really need it for this type? Like, or why don't I just expose these fields and let the developer change, set them? So I don't really have like a specific, yes, you should use them, no, you shouldn't type thing. For me, it was just stepping back and deciding, case by case, is it necessary? And if it wasn't necessary, I just tried not to do it because it didn't seem worth the effort. The other thing that I would add is that if you are using a constructor, I think the common approach that people take at first is to write like, if you're writing a thing, you write like a new thing function that creates it. And I think there's a lot of times where you can make your constructor function a little bit more clear as to what it's doing. The database SQL package is a good example where you call SQL.open and it returns a DB instance. I think that makes way more sense than SQL.newDB, which isn't really clear what it's doing.
So if it could be like a verb, you think that?
Yes. If you can like explain what it's doing, I think that makes more sense.
And you're allowed to have multiple names in that case, because you might construct something by performing different actions.
Peter.
Yeah, like in any language, there's not like one answer that is generally applicable, right? Sometimes constructors make sense, sometimes they don't. The one thing that I think is important to like understand when thinking about this question is this fact of Go that, except for very few exceptional circumstances, it's always possible to construct a type, the zero value of a type, right? Basically, there's no way to avoid allowing your callers to do that, right? So the zero value of a type is always something that can exist. Okay, so with that in mind, it would be cool if the zero value of the type were like useful, right? And that's also like a proverb. If you can create a type where that is true, then like, all else equal, maybe that's a good idea. You don't need a constructor. You can just like use it in a useful way without needing to initialize it. Now, of course, that's not always possible. If it's not possible, then it's probably better to use a constructor because that gives you, by convention, control over what I say by convention instead of like, it's not enforceable by the compiler, but it gives you some control over what the state will be in a way that like setting fields in the caller context doesn't. So pros and cons, right? Pros and cons, no single answer.
Have you ever written a destructor?
It's not possible in Go. It's finalizers, but that's something else, I guess.
Yeah, have you ever written a finalizer?
No, I haven't.
I have, but it was almost always a mistake.
Okay.
I'm glad I haven't now. But that's interesting about the zero value. There are some examples like the bytes buffer. You can just kind of say, I want a bytes buffer, and you can start using it immediately. One of the things you get with constructors is you can take in required arguments into the constructor. So then, of course, it's not possible to get the type according to the API without providing those values. Of course, the zero value is always there. I think one of the other counter things I hear is that in a way you're hiding what's happening. You could be spinning up Go routines. You could be allocating all kinds of memory inside a constructor. And by avoiding a constructor, it makes it very clear what's happening. If you're asking your user to create the instances, they see exactly everything that's kind of going on. But to be honest, I think for me, the convenience, I went through a similar evolution where I used to always create them. And then I went off it and I started to just try and get the zero value to be useful. And then almost all of those types evolved eventually on their own into basically needing a constructor. So yes, but for me, it depends on the case, which doesn't help. For services and things like this, if you've got these sort of service level objects, structs and things, then I do tend to do it because usually they have dependencies and it's a kind of a nice way to tell that story. But yeah, it depends. If I was building some lower level thing or something, that had more of a data structure kind of component to it, I think I'd probably think maybe differently. What do you think about those, the options as well, a way of customizing things by passing in little option functions which can then run and modify things?
Functional options as a configuration pattern, right?
Yeah, right. What do you think of those?
I can start by saying that I don't like builders that chain. Just in Go, they just don't feel right to me half the time. I think they're just, I don't know. It probably comes down to like I've been bitten by error cases where like one of the ways they'll handle errors in a builder pattern is they'll have the created object have like an error field and you're expected to check it once you built it.
Right.
And I think it's really easy to miss that. Whereas if you use functional options instead, it's much, much easier to make your constructor actually return the thing and an error. And you know clearly what happened.
Mm-hmm. That's a good point, actually. If in creating or in constructing the thing, if something could error, that is probably a case for having a constructor, isn't it?
Yeah, I agree.
We're all nodding our heads for people who can't see us.
Yeah. And even for the builders that you were talking about, what do you do if something in the middle of the chain errors? Does everything else become a no operation? But what if some of the parameters that were passed actually call the function or stuff like that?
Yeah.
And in that case, do you just return the error at the end? And how do you know what was executed.
The ones I've seen that have done it well with those Fluent APIs, they just change state. They're basically just changing internal state in a controlled way. They can't error, so that's why. And then usually then there's an operation at the end, which is the big operation, and that one will return an error potentially. But they do make testing hard, or they can make testing hard if you want to stub things out or, have some kind of abstraction on that stuff. They can get in the way a little bit since they're returning the concrete type often. So you can't do the trick of creating your own test interface in order to provide different mechanisms for it or a different implementation.
Right. The one good use of builders that I've seen, and recently I had to use this, was for security reasons. Like, we wanted to make sure that a certain object was constructed in a precise way by passing arguments in a certain order, and nothing would ever happen out of order. So basically, in the middle of the chain, you would call a certain function that would return a new type. And on that one, you could specify more stuff. So basically, we returned types that were not the entire thing, but in every phase, you had to specify some things, and then you had to move on to the next state.
How did you name those types? That sounds like a nightmare.
We still have to decide.
Yeah, that doesn't sound like an easy problem, because they're all the same thing.
He's like, we started this 6 months ago and we still haven't decided.
It's just going to be 1, 2, 3 in it, I bet. Step 1.
This issue was open a month ago and we haven't decided on the names yet. So yeah, you got the problem with that.
Yeah.
But wait, I'm trying to understand. So you have like a thing at a high level, which is like, in the end, a sequence of sub-steps or something like that, right?
Yeah.
And you're using the builder pattern, you're modeling the sub-steps as different types, and you're using the builder pattern to like move from one sub-step to the next. Is that right?
Yeah, basically I can give you the concrete example. We are building a framework to develop web applications. And when you set up your entire server, you register handlers. After you've registered handlers, you're supposed to register plugins. That is something that will intercept requests and responses for security reasons. Most of the logic will just be in handlers. And then after you're done, you start a server. And at that point, you are not supposed to change nor the handlers, not the plugins anymore. And vice versa, when you install a plugin, it's too late to register a handler at that point. And we could do this by panicking if you did things out of order. And this is still on the plate. But we found out that checking this at compile time, like making sure that if your code compiles, you did stuff in the right order, felt like a good thing to provide.
I've genuinely never seen that as an example in Go.
I would love to have a deeper conversation about this because I have many, many more questions that are not, I guess, appropriate to this to this call. But okay, let's see.
Yeah, we can discuss it later.
Interesting one.
Just maybe quickly on functional options. I really liked them for a long time. But another thing, to think about the actual property of the language or the invariant that they encode. It's like, you can always, if you're using functional options, your user can always not pass any, right? That is a valid state, which means that functional options are always like, you can always create a 0 value for a type in a sense, right? If by not passing any options, which means that they're good when it's rare that you need to change anything away from the default value, right? And when you do, you only want to specify like 1 or 2 things that are different. So if your type has like these semantics, then they can be good. But with that said, I rarely have types that work that way. And when I do, it's often equally easy to configure them in a different way. This has been sort of my experience. So these days, I don't really use them anymore. I think the way they kind of pollute or change the Go doc for a package or like make it slightly harder to understand, outweighs the benefits that they give you.
Okay, well, moving on, we have another question here from Data Charmer, and I'm going to paraphrase this, but it's basically saying, you know how when you parse dates in Go, that's weird, isn't it? This magic date that is kind of, it's Monday and it's January, it's like a really specific time. Why is it like that? And do you think it's weird?
I'm so confused by questions like this. I'm so confused.
Why?
Because everything in a language is like, they made a lot of decisions, right? Why is it func and not fun or function, right? Why are declarations in the order they're in? Why can you do var blocking with parentheses? Why can you not do const of byte? There's so many things that just are, right? And so
So you just accept it.
It's just something you have to learn, right?
It's just the law of physics.
I would say that's beautiful, actually. That's one of the things I like the most about the date stuff in Go. Because when you think about parsing a date, usually you have an example in mind. It's like, I've tried to use other libraries, especially Java ones, for date parsing. They're not intuitive at all. Yeah, the Go one is odd, but once you've understood it, it's very easy to use. It's like you just write a date in the format you expect it to come, this is like user-centric APIs.
It's not hard.
Yeah. Except it can't be it's not your date, is it? You have to use the right values in each slot, essentially. And they're numbered, aren't they? It basically counts up if you notice they...
Yeah, exactly.
Yeah, but that is odd.
But you have to remember 1, 2, 3.
It doesn't help that the example they tend to give doesn't show it obviously that it's counting up.
Yeah.
Like the one they give is like Monday, I think it's usually like Monday, January 2nd, 15.
304, 05.
Yeah, and like the way it's put there, you're like, you don't realize that it's really going 1, 2, 3, 4, 5. Right. Because like 15, well, that's 3, but like people don't quite realize that it's 3 p.m. Like that, throws them off.
And MMDDYYY, these, that style kind of, I feel like that is used in more places. What do you think?
I think the hard part is most MMDDs have like capital M's and lowercase m's and they mean different things.
Weird. That's true.
And you still have to look something up. So I think at the end of the day, the short answer is that you're going to have to look something up. Looking up a specific date is really not that big of a deal compared to looking something else up. And there's tooling that makes that easier.
Yeah, like I always have to look up the surf time stuff personally. I never remember that.
Okay, well, I'm with the questioner on that. I think that is a bit weird, but the answer is that's just the way it is. This actually could be quite easy. We could just hammer through these with that, if that's our answer.
That's just the way it is.
Yeah. The next one, actually, which we got a couple of times, is how come there's no enums or enumerators in Go? So this is that thing in other languages where you get a kind of compiler time way of declaring a set of values that are only valid for a particular type, and you get kind of compile time help there. It's useful for if you've got, say, a status and you've only got 4 different statuses that are possible, you can make types give you kind of safety there. What do you think about that? Because there is the IOTA pattern, which is basically how we do it most of the time. What do you think about this?
It's the only feature that I'm missing Go. Like that is the one thing that I would add to Go. I would not add generics. I would not add many other things. Enums is the one thing that I miss.
Yeah.
Go ahead, Peter.
Please disagree.
No, I just wanted to say it would be nice, definitely.
Oh, you've not disagreed? Oh, I'm sorry, it's supposed to be controversial.
You didn't do it.
Next one, when we talk about frameworks, we'll get into the weeds.
Okay. But John, you were going to say something about enums.
I was going to say, IOTAs terrify me because I always worry that like somebody's going to insert a random one like in the middle of the IOTA values and all of my code just going to break. Like every time I go to use them, I get terrified of that. And I end up just like writing strings for everything because I'm like, I know these are going to work if they're stored in a database or something. Am I the only one that feels that way at times?
I'm also afraid of IOTA. I tend not to use it.
To be honest, I use strings.
So the advice we give everybody, we don't use.
Well, that's the Go way to do enums, as I understand it. But yeah, the alternative is just to have constants with strings or constants with integer values. You can still document them, can't you? You can still describe it. And usually if you use a prefix, that's quite a useful way. HTTP status is an example. They've got all the status codes as constants. And they've also done the HTTP methods, which I don't know if we needed those, but we have them. So you can do like http.method get, method post, method patch.
But that is weird.
Yeah, it's longer to type that than to type the string.
Right.
It is, but I don't know. I found that it doesn't bother me using it.
Okay.
Especially with autocomplete and everything.
Yeah.
Right. It was like, does it mean that we expect the get verb to change from get to another get? Because it's like, that is here to stay. I don't know.
Yeah.
That feels weird.
Yeah, I probably wouldn't have done it, but it's fine. It's completely fine. You could make the same argument for the status codes. And frankly, I find those to be much more readable, especially because I don't know all the HTTP status
exactly.
codes.
That makes sense because you read the words instead of the number.
Right.
I didn't actually know that the methods were defined in the HTTP package.
Oh,
yeah, exactly. There you go. So you don't use them.
At times I feel weird not using them because I'm like, somebody's going to be like, why aren't you using constants? Like, why are you hard coding strings in here? And even with status codes, I'll occasionally write 200 because I'm like, if you're writing a web service and you don't know what 200 means, you probably need to go figure that out first.
That's true. 404 is another one that it's actually seeing status.not found to me isn't as clear as 404.
There's a couple that are like that.
Yeah.
Like, you know, there's just a couple that it's like, if you don't know these ones, then you should probably figure them out. But then there's other ones where, okay, I get it. This one's not quite as clear. So I have mixed feelings on that at times, but I tend to just use the written out, you know, status okay or whatever, just because I want all my code to be consistent. But sometimes I'm like on the fence there.
Yeah. If I want to say like as a string, like posters will post you a t-shirt, I'll use the post const there. So I go the other way and use it way too much where you shouldn't use it. That's a joke, by the way. Any beginners, don't do that. It's be crazy.
Tell jokes or...
Yeah, don't tell jokes. It's
a tricky game.
It's a tricky game. Especially when your editors are not kind to you in the edit, as tends to be the case for me. Okay, so shifting gears a little, when should we inject dependencies? Maybe we could just have a quick overview of what we mean by dependency injection, and then we could talk a little bit about that. Who wants to tell us what is a dependency injection?
If you mean when should you pass dependencies to things that need them, the answer is always, never not.
Yes, but what about like an abstracted? Do you believe in any sort of abstracted dependency injection mechanisms, or is it just a case of pass arguments because then you get all the compiler help?
I like to have a struct when I build web service, especially that keeps all the dependencies that need to be injected. So it's like if I need clockwork just to have a static time that I can measure in my tests, it is fine to inject time, or like inject a random source, like have a crypto safe random source, a startup on the real server, and one that is unsafe and predictable in the tests. But I despise with all my strength dependency injection frameworks. I do not like them.
And that's what a lot of people, I guess, mean when they ask about dependency injection. They mean like the thing that sort of figures out your dependency graph for you based on like annotations or something like this. I agree. I understand some circumstances where they might deliver value, but I think they are so rare that anyone who's asking the question shouldn't be using it, basically.
Yeah, I think I'd agree with that. You can't go wrong with just having fields and setting them. And if you do have constructors and there's a service that relies on other services that you have as different structs, then you can take those as arguments or have them like in the struct on the type or whatever. And that's very clear. And sometimes when you're then adding something, when you want to add a new thing, there is then some plumbing to go and do. And that's the bit that, because it's repetitive, we want to dry that up naturally, I think, as programmers.
That's such an interesting point, right? Because you say there's some plumbing to do, but I see that work as like so virtuous, right? Because it's not just you doing like this rote mechanical stuff. This is you expressing what is now a new truth in your application, right? And there's this thing which is now being used in this sort of like dependency chain that is now like visible, right? Someone new to the code is going to see that that's there, and it's needed for these things, and like that's so important to make explicit, right?
So it's very rewarding, and usually it's quite easy work too. It's just a case of looking at another service, going and looking where that's wired up and doing the same. So it's quite easy, but you're right, it is quite rewarding. There is something very satisfying when you get to the point of actually exposing that service. It does feel like a bit of a milestone. That's a good point.
Right, and it allows you to do more granular things. Like in dependency injection frameworks, one thing that really happens is that they compute the graph, and to serve a response, they will need to build up the entire graph and construct most of the things, even if you're not going to use them, because they don't know if you're going to use them. But one thing that I like to do in my web service, especially if I use cloud services, I use sync once everywhere to construct my stuff, so I know that stuff will be constructed only if I actually need it. And it's very hard to do that if you just inject magical things that depend on other magical things.
Yeah.
Like I like to do the things that I need to do, not more.
Right. So by default, try not to do anything, and then when it's needed. And that comes down to also like the environment in which you're going to deploy the code, because if you put that into a situation where it scales down to 0 instances automatically very often, you're probably going to get a big saving with only doing things on demand. Whereas if you've got services that run for a long time or they're just permanently running, maybe it's easier to just get all the work done up front so you know it's going to succeed, and then you can kind of go from there. So I think, those kinds of decisions I think matter more for sure.
This type of question is hard for me because I agree with you guys that most of the time when it's asked, it's somebody coming from like a Java background or something where they're expecting to inject things with a framework. But on the off chance they're asking like, when is it better to just put an actual type embedded into a struct versus, or not necessarily embedded, but as a field in the struct, or to like put an interface instead? I think for me, it just comes down to, are you actually going to replace this with something else at some point, either in your code or in your tests or something? And if so, then the interface makes more sense. But if you're not ever replacing it, just start with the struct. It's really not that hard to change later.
Why is there this natural aversion to this? Do you think that there's something about the fact that just setting fields on a struct feels too simple and too easy and therefore not professional in some way? Especially if people are used to big enterprise frameworks in the past.
I think some people just don't like having a main file that has all this like setup of like, okay, now I have to initialize this thing and I got to assign it to all these different structs that need it. Whereas if you come from like a framework, like a Rails or whatever, you don't do any of that. It like does all of that, whatever assignment needs to happen, everything happens automatically and you just access the things you need. So I think sometimes people are looking for this. Essentially, they want to have some like global DB instance that they can connect to, and they don't want to have to inject it anywhere. They just want to be able to access it. And I think they don't quite realize that down the road, that could potentially introduce some problems.
Yeah.
I feel like people feel like that until they need to debug it. Like they like the magic until they need to find what's wrong. Because for me, having everything magically injected was beautiful until I had to find out who was constructing that.
Yeah, that's true. I think of any time you use a pre-built framework or an abstraction or something, you then are kind of tied to its decisions. And if you then have to fight it, it can get very unpleasant. And that's, I think, a lot of people I hear talking about avoiding frameworks are coming at it because they've been burned so many times, and so that's why we talk so much about this avoiding early abstractions. I think it was Ben Johnson on Twitter made a good point about this, he actually made the counterpoint, which was sometimes the right abstraction basically is amazing, is so powerful that if you do find that abstraction, then you really can enable a lot of, unlock a lot of potential, enable lots of people to do things. That's why I think they're so attractive, but they're a bit like the Holy Grail. They're difficult to find. I think the Holy Grail is difficult to find, if I understand it. Anything else on that? If not, we have a question about init, which I want to put to Peter.
Peter, why are you doing this?
Well, I know we're going to get a good answer. What about init? When should you use init, Peter?
So let's, as we've done a lot in this episode, go back to like, what are the mechanics of this thing, right? What are the truths of this part of the language? Well, init is a function that runs when you import a package, or runs as part of program startup, and it's run before main starts, and like a product of how it exists in a package. All it has access to, like by definition, are the package level consts and variables and the package level declarations, right? It doesn't have access to any state that isn't declared at a package level. So init, by like design, its only purpose is to manipulate package global state, right? That's the only reason it exists. But you shouldn't have package global state, right? There is no, in general, you should try to avoid it. I take it a step further. I say you should actually never have any. And so therefore, for me, every instance of func init is a huge red flag. You're doing something in there which ought to be done somewhere else.
Yeah, I concur with that. I would say just avoid init. It's a bit too magic, and anything that's too magic like that becomes a problem later. It's so fun when you're first doing it and it gets things working. When you're writing, it's fun. But yeah, when it comes to debug code and figure out what's going on, that's just too magic and probably worth avoiding. John, what do you reckon, mate?
So I guess my only caveat to that would be, like, let's say you're writing a SQL driver. And pretty much the convention at this point is to register your driver via init. And as much as I wish that would change, I think at this point you're better off just doing it because that's the convention. But I don't love it. It's just one of those, like, because that's convention at this point, trying to change that is not worth the effort. Just do it.
So this is that thing where just by importing a package, its init function will register itself with another package.
Yes.
See what I mean about magic?
Right. And like, this is I hope it's uncontroversial to say, and this is like a design choice that was made in like pre-V1 of the language, that there would be this global registry in package DB, and this would be basically the way to like use it. And like, I hope it's uncontroversial to say that this pattern has like not stood the test of time. This is not a good pattern, right? And so to use the global registry in package DB, you have to do it this way, and that's true, and it's too bad. But if you're writing your own package, do not copy this pattern, right? This is not the way to do things.
What's up, Gophers? Do you have an app in production that's slower than you like? Of course you do. I know. But seriously, is the performance of your apps all over the place? Sometimes fast, sometimes slow? Do you even know why? Well, with Datadog, you will. You can troubleshoot your app's performance with end-to-end tracing, and in one click, correlate those Go traces with related logs and metrics. You can also use Datadog's detailed flame graphs to identify bottlenecks and latency in your apps. Start tracking the performance of your apps today with a free trial at datadog.com/GoTime. And here's a bonus. If you sign up for a trial and install the agent, Datadog will send you a free t-shirt. That's a nice bonus. Once again, datadog.com/GoTime.
I think probably our final question, this is going to be a big, meaty one. We get this a lot. I certainly get this a lot. And it actually turns out to be a very difficult one to answer, but we're going to do our best. Or your money back is free. You get to forget the ads. That's the way we'll refund you. You can forget about all the ads from this podcast. The question is, how do you structure Go code? And this is something that people care a lot about. It's the kind of thing that for beginners is very intimidating. We know you can learn the mechanics of, well, this is how packages work. This is how you import packages. But what about when should we build a package? When should it be in main? How should we structure this? Because of course a package is a folder in Go. So now we're dealing with folder structures and things. So this is a question I get a lot. So I'm just going to ask you now, how do you structure code in Go?
So I think we can all agree on the general idea of creating a CMD or command folder, and inside of there sticking your different main packages. And generally those just sort of initialize some state and start the program. From there, I think that's where it gets more confusing for some people. Trying to figure out where to put the rest of the code and how it gets organized. So I'm just going to say, let's assume we have that. My general advice is stuff that I don't think people like to hear, but I really do think starting with a flat structure and waiting until you see a good way to break things up is the best way to go. Now, I will say that I have shown people how to do MVC simply because I didn't want them to think about it any longer. I just wanted them to get their stuff up and going. And I'm like, later we can come back and figure this out. But for now, your goal is just to write some code. I think it gets asked so much because I think it's something that blocks people from moving forward, and it shouldn't.
A lot of languages have this, I guess, convention of all of the project structures being roughly the same for the same type of project. Like if you're doing a web service in Ruby, you're going to have this layout, and the packages or whatever are going to be named after the architectural patterns you're using, right? MVC, for example, right? Controllers, blah, blah, blah. But in Go, that's not really what we do. We have package and project structures that are basically reflective of the domain of the thing we're implementing, right? Not of the patterns we use, not of the scaffolding, but of the specific types and entities in the domain of the project that we're working in. And so it is always like idiomatically different from project to project, like by definition, what makes sense in one doesn't make sense in another. Not to say this is the only way to do things, but this is what we tend to do. And so, yeah, there's no answer. And that kind of like truth about what is idiomatic in the language is extremely confusing for a lot of people. And maybe the wrong choice as a result. I don't know, but I think that's the main point.
I think it can be quite liberating, though, to say that there isn't really a way to do it, which also means you can't really do it wrong. It's what fits for your case. And if you're not sure yet, then just sort of defer it. Worry about it later if you can. It doesn't always work like that. And of course, if you're talking teams at scale, I think that's a little bit different. It's sometimes then worth investing a bit of time and trying to do some kind of design that, based on what you know about it. But yeah, I personally follow the approach when I'm building something new of I just have a single folder. It's got a main in there and then all the types. And I just use file name prefixes with underscores actually to group the functionality up together and then have it all kind of together. And then, later, if say we have to deploy this other service in a different way or something changes like that, then I've got a good reason to go and have a look and make some changes. But I'm doing it in an informed way.
I would say that the sentence that you said is that since there is no scheme that we all adhere to, you can't get it wrong. I would phrase it differently. I would say that since there is no mandatory structure, you might have a chance to get it right. Because so many times in a project, I had...
Less optimistic.
Right. So many times in a project, in another language, I had to force my structure to adhere to the framework or to the language. That it made no sense for me. And it was impossible for everyone to browse it. Because if the structure is the same for every project, it gives no information, right? It's like sometimes when you visit a package, the package structure already gives you some information. And in other languages, you lose that chance.
So do you think that within a project, you might even have contradictory kind of things? You might have some things laid out one way and other parts laid out differently because it happens to suit.
Yeah, I do, because I tried. To the question, how do you structure your packages? My answer is the best way I can for the user. And if I think that the user will benefit from one type, for example, being the exception of a rule that is general in that framework, in the thing I'm building, I will do that. I will have that type stick out in another thing. It's like cookies in HTTP. They're a header, but they're not treated as a header in the HTTP package. And that makes it so much more usable. And I think there's a good reason for that.
I will say the one thing that I have seen is that people will try, like Matt says, there's no wrong way, I guess. And I agree that you should go try things because truthfully, if something is, I'm going to say wrong in quotes, not really wrong, but if something doesn't work, it's easier to understand why it doesn't work when you actually build it and start to actually experience why it doesn't work. And one of the common ones that you'll see is they'll end up with cyclical dependencies where they're trying to import multiple packages this way. And I'm curious to get your take on this, but what I've been trying to advise people lately when I talk to them about this is I know nested folders don't really matter for packages in Go, but I've basically said to try to think about your code almost as if you can only import things going up the tree, like in your packages. So if you think about it that way, there's no way you can possibly have.
What do you mean by that, John?
Okay, so let's say your root level, you have like an app, like you just call it your app package. Underneath that, you might have like a SQL package that you're writing your database stuff in. And then inside of that, you might have something even more specific, like a Postgres package or something.
Right, specific to database.
So like the Postgres package can import the SQL package, and it can use whatever types in there, and it can import the app package. But those ones can't actually import the Postgres package. They have to define an interface that the Postgres implementation would be used to satisfy.
It's funny because I've done that the other way around, where you can only import packages that are inside, and you do it the other way. It's the same kind of idea, I think, but I wonder if we're saying opposite things.
I'm kind of viewing it like, it might be similar. I'm kind of viewing this as like, you have a central object and it defines sort of all your it's like if you've ever read Ben Johnson's standard package layout, it's the same idea. You have a central like app that defines interfaces, and then as you expand, you get more specific implementations, and you might still have interfaces there that get implemented by even more specifics. And it's a little bit tricky because as you work your way out, there's always going to be people who come up with some weird edge case. For instance, if you're using like an ORM, you'll be like, well, my app might have a user type, but then my ORM has a user type that's like representing what's in the database and like which one's correct. And I tend to treat that, if you're going to use the ORM, at least at this point, my suggestion is generally to treat it like an API where your application might have, a Stripe charge or some sort of like, object representing that internally. But then the Stripe API has their own representation of it, and you have to translate between the two to get it into your application. And there are some downsides to that. Like, I don't think it's perfect, but it tends to get you going in the right direction without, cycles in your dependencies and things like that.
So Ben expressed this really well. I think at one point he said packages should stack and not interrelate, right? So there should be a clear like stacking effect relationship between packages. And this is another way of expressing in the clean code or hexagonal architecture or domain-driven design. They call it the inward-facing dependency rule. Like your HTTP package can import your business logic, but your business logic cannot import the HTTP package, right? It should only go in one direction.
Yeah, that is key. And that's when we talk about things going wrong or not working from a structure point of view, is usually like cyclical dependencies, like you say, John. And those kinds of things are easier to avoid if you just have one folder. So that's another reason to sort of just avoid those problems early by doing that. Yeah, but well, it's that time of the show where we do our unpopular opinions.
I actually think you should probably leave.
We did have an unpopular opinion from Reddit, and it said, unpopular opinion, this is from BK Limksak. And BK Limksak says, the simplicity of Go makes it less useful in some use cases, which I think is probably has some truth in it. There probably is a trade-off there. What do you think? Well, we don't have to debate that one. Do you have any other of your own unpopular opinions?
I think we can. I can quote Brad Fitz on this, in which he said that Go does everything you need, 100% of what you need, 80% of the time.
Sounds like something from Anchorman.
Which is true. Sometimes Go doesn't cut it, and that's fine.
Yeah.
Like the simplicity and the benefit of having that hard, opinionated language, very opinionated language. The benefit is overweights the downside of not being able to write some code sometimes.
Cool. Any other unpopular opinions?
Well, apparently, Chris James has one, but I don't remember it in the Reddit thread. But he says if we don't say it, he's going to riot.
Okay. So we're not going to say it then, obviously. Because we do not negotiate with terrorists on this show. We never have. They might tolerate that kind of thing on JS Party, but not on this show, baby. Or we can just do it, though, if you want as well. Peter, do you have one, mate? You didn't strike me as the type.
Well, unpopular to who? Unpopular to who? What audience?
Most people. I think it just has to be most people.
51% of people.
51%. Yeah.
But you get to choose which people.
Which people?
To like Go people or to programmers in general?
I don't know, any.
Who am I offending? Yeah.
You can go this way. You set the group, and then you say the opinion. Like you say, this is unpopular in group, and then you say...
Yeah, it's like targeted.
Right.
I didn't know this was a tradition, actually, so I wish I had prepared a little bit better, because I'm sure I have lots of really offensive beliefs in here somewhere.
So maybe it's better that you didn't.
No. We'll drag up something, and I'll try to keep it pithy in the tweet format. This is maybe a little bit easy, but that's fine. We'll go with it. I think that in almost every case, if you're choosing whether to bias in favor of more work for you as a programmer, if it makes the reader of your code do less work, in like every case, you should make that bias.
Optimize for read.
Yeah. And like the metric of how long it takes you to type code into your editor is approximately never worth tracking. Like it's just completely irrelevant. And like anything that is like a optimization for that metric is incorrect 100% of the time.
Great.
But what if I'm writing code that only I'll read and I'm very sadistic?
Don't bring us
Or like
into
I'm a
your-
masochist
don't
or
bring us
something. I
into
don't
your
know if you used the right word.
fantasy
But
What John does in the privacy of his own dungeon is his own business. In his
write
own
this code thinking,
code dungeon.
gonna have a real treat for myself later when I try to read this.
Well, that's usually how we really learn these things, is because we have actually done that and we hate ourselves for it. So then we think, oh, let's not do that again.
And then you do it again.
Yeah.
Yeah.
Once I tried to reread some code that deeply used map, filter, reduce chains, and I decided that it would have been easy to rewrite, trying to remember what it was trying to do rather than understand it. Don't do that to yourself or to anyone. It's just don't do that kind of stuff.
Yeah, that's interesting, because actually I like, if it's small enough, I quite like that. I like that I can actually just rewrite it, because usually then it's better because, there's some time has passed since I wrote it when I didn't know anything about it at the time I wrote it.
Right. You write the code right on the third time, right?
Yeah, if you're lucky, yeah.
Right. About being, a ray of sunshine in this podcast.
I think one of the other things to keep in mind there is just the fact that if you're going to rewrite it, at least if it's for yourself sometimes, this is I view it as, I'll rewrite it better later, but if I never actually get to rewriting it, I save myself some time because it didn't really matter. I'm not looking at this code. So there are cases where I'll just be like, I'll do this, refactor it later. But I think I consciously make that decision. It's not like, oh, this took me less keystrokes. It was like, look, this was just me getting the first version done.
Yeah. Or sometimes if it's only going to live for a little while, you just want to do one thing on your machine and you need to just crunch through some data and then you're going to save it somewhere or something like that. It's a one-off. You sort of then, it doesn't matter. I like to still kind of do it as exercise to write kind of the cleanest code I can.
Yeah, also because these things grow, don't they? It's like, let's say that you start with a small Perl script that processes some data in one line, and then after a while you're like, I need to make this scale or use it for more than one thing, and you have to do it again.
Yeah, it happens all the time. Someone wrote one script to scrape some university website, and that thing's grown, and now it's
Facebook. Yeah, exactly. It's the worst. Yeah. Then this is an interesting thing that we probably don't talk about nearly enough, which is we're saying all these things you should do this, we don't like that, this is a good idiom, this is a bad idiom. But the context of all this stuff is maybe unstated. It's stuff that code you're writing with other people, right, in an organization. None of this really applies if you're just writing some code that generates a fractal or something. Do whatever you want, right? We're talking in the context of how you can be a good citizen in an ecosystem, right? So maybe it's worth making that point a bit more explicitly. I don't know. Yeah,
I think it's a good point because context actually applies. It changes lots of things too. Lots of advice changes with context. If you're just a tiny team of 2 people, you might well behave very differently to even a team of 8. And certainly a team of 50, 100 people, you're necessarily going to have different attitudes, different problems, different ways of interacting.
And this is interesting too, because Go itself is biased for programming in the large, at large organizations with lots of engineers who come and go on big teams, right? That is explicitly what it's targeting, right?
Yeah, because the readability, right? The focus kind of is that optimized for read. So, I think that's why lots of people learn it quite quickly. It's because it's smaller, it's optimized for read, and it's kind of easy to get going with. The tools, once you download it and install it, it's kind of got everything you need and a bit more. So I think it is kind of, great for that. Roberto, what were you going to say?
I'm just saying that this also influences the community. It's there are communities which the smartest code that you can write is a beautiful piece of code. And I'm totally fine with that. And there are communities like the Go one in which if your code is too smart, you might want to consider dumbing it down a bit because that's going to be hard to debug and hard for newcomers to start understanding whatever you're working with. So it's not just that the language influenced the libraries and the ecosystem, but also now the ecosystem influences the way we write the language to keep it simple and maintain that tradition, which is something I like.
Yeah. Well, I'm afraid that's all the time we have. Very sorry if we didn't get around to your question, and probably just means, this wasn't interesting enough. No, we just didn't have time. There were so many great questions, and thank you so much. We will do another one of these again because I've learned loads, and I'm sure other people have too. Thank you so much to our guests, Peter Borgen, Roberto Clapis, John Calhoun's also here, and I was here too, obviously. See you next time.
Comment on this and every episode of Go Time on changelog.com. There's a discussion link in your show notes for easy click-ins. We would love to hear from you. And don't forget to follow the show on Twitter. We are at GoTimeFM. This episode was hosted by Matt Ryer and John Calhoun. It was produced by myself, Jared Santo, and our music is provided by the Beat Freak, Breakmaster Cylinder. Shout out to all of our longtime sponsors. Thanks again to Fastly, Linode, and Rollbar. That's all for now. Brad Fitzpatrick joins us next week.
So if anyone's wondering why Matt has a team with just one other person, it's probably comments like that.
I'm the nice
many
one.
other reasons.
You're the nice
I just thought
one.
of a much better controversial opinion, unfortunately.
No, you can do it. We can
We're
edit
still
it in.
live, so yeah, it can get edited in or whatever.
Still recording.
Well, I mean, like maybe not worth it, but yeah, like I've spent a lot of time thinking about the semantic import versioning rule in modules, and I'm like increasingly convinced it's just a complete design error, and modules is like fundamentally broken in this way. But no one seems to agree with me, so maybe that's a deeply unpopular opinion.
We did have a question about which Go version you should choose in the Go mod file. What do you think about that?
Yeah, well, it doesn't matter, right? At the moment, that it doesn't really have an effect. In the future, it might, but at the moment, it just like doesn't really matter. If the question is like which Go version you should use in general, it's like the latest stable release always, right? And like definitely.
Yes, and I've had a problem with that because if you choose the latest stable release for library, that for example relies on the SQL package, in Go 1.15 a function was just added, and my library is a wrapper around the SQL package, so I had to write two versions. That one that was more backward compatible and one that works with the new one and exposes that function. Yeah. So for programs, it's easy, just the latest. For libraries, it's not that easy, in my opinion.
Good stuff.
I wish I could say the latest that compiles with this code.
It's hard for me to talk about like the versioning stuff because I'm just not in a situation where I run into the issues that some people have. Like my dependency tree is not that complicated. So as a result, it's like what they have is fine. So I kind of view my feedback on that as I don't have, like I can give you the just somebody throwing something together as feedback, but really the complicated cases are going to come from like Kubernetes or some big project like that, not mine.
But do you have projects that have a reasonable rate of change?
Yes, but it's probably not library changes as much. Like library changes are not, like it's whenever I decide to go back and change them, I guess. For the most part, once something's in there and I used it for the things I'm using it for, it's pretty good.
Okay, and so you don't tend to have things that evolve every time. Lots of contributors are like
no. Like right now, no, I don't have any like many projects like that now.
Yeah. Okay.
Yeah, that would be different, wouldn't it? Especially if you when do you release? You suddenly have to release to tag versions and things.
Right. Which semantic import versioning makes like a much bigger deal out of than, in any other ecosystem. And that's like the entry door to my like Pandora's box of complaints.
Mm-hmm. Well, maybe we'll have to do another episode on that altogether, Peter.
I would love that so much. And if you could get Russ on so I can understand his perspective a little bit better, that would be even better.
I think you should make an episode on rants. Just you bring people that have complaints and you throw them against someone that caused like that pain.
Like face your oh yeah, it's grim, but yeah, like justice. You get some justice. Yeah, I don't know, because we're quite nice, aren't we? We're all a bit too nice for that. Sounds like a roast. We could do maybe we should just do like Gopher roast, where we just get Dave Cheney and we just write loads of horrible jokes about him.
Sarah Silverman probably too. Yeah,
yeah, get Sarah Silverman up to do a bit. Jeff Ross will be in there, obviously. Yeah, no, okay, won't do it then. Didn't get the support I was hoping for on that one. Gorilla Gopher. Leah Anthony on Slack said Gorilla Gopher.
Gorilla Gopher, if it is a voluntary, like the person agrees to that, why not? We might end up learning something.
Okay, yeah, fair enough. Gorilla Gopher. I don't know. I don't think it's right for our community, is it?
No, also a lot of people in the community are vegetarian. Doesn't sound good. Right. Gopher is an animal still.
You can still grill vegetables though.
Right.
It's a gopher like a person though, don't worry. It's a person. It's not an actual gopher animal.
Right. Yeah,
like
I got that.
If they're prepared.
Yeah. If the community guidelines don't say anything now, all of a sudden there'll be like an addition. Like we had to add no grilling gophers. It's not
I haven't seen it say you can't grill gophers in the code of conduct personally. And I read them every day.
Just to be sure.
Yeah, just to be sure. Yeah.
In other news, we have an opening for a GoTime panelist.
Yeah.
Because Matt's going to lose his job.
Okay, all jokes aside, Matt, have you ever hunted and killed a human being? The most dangerous game?
Oh, no.
Oh, you really should. Oh, it's so thrilling.
Oh, yeah.
How do we get so dark so soon? Well,
I feel like it's time to go off live.
It was so sudden.
Yeah.
Or are we still live?
We are.
Yes.
Yeah,
Sorry.
It's all right. It's obviously a joke. I don't think
Obviously, it's a joke.
I don't think anyone listening would not think that was a joke. But the answer, Peter, is no, not yet.
That's okay. Yeah, very good.
Yeah.
Very good. I'm going to wait for the purge, kind of like post-apocalyptic thing. Yeah, no, it's probably more thrilling that way too.
We could have Go for Purge, where we just delete all the libraries that we don't like. Just one day where we can forget the consequences, just go around, delete all the libraries. And then
there's a fun game. If you could delete one library from existence.
That's quite a fun game.
Oh. One library.
One package. A Go package.
Yeah, and force everyone who's using it to use something else.
Loggers.
I feel like Peter would just be like, we're going to delete SQL database or database SQL just so we can fix that init function.
Or like that has an alternative, or would you build the alternative?
Doesn't matter.
I mean, I assume they'd have to rebuild something.
Someone's got to.
Oh, it doesn't matter. HTTP, like every day. That is old.
What's wrong with it?
That is old. Client and server in the same thing, content type sniffing done in the worst possible way. Too many default things, recovering panics. Too many things. It's like I have a document.
Right, design errors. The main thing I think for me is like allocations, of course, too. Right?
Yeah, also there, but I'm not that. Like I care about performance when it's the last concern, and I have a 24 pages document with the other concerns to be addressed before performance.
That's too many pages, mate.
So, Brad, that's a shot across the bow to you from Roberto.
Brad Fitzpatrick is on next week's show, so we'll absolutely be playing a clip of this and getting his reaction.
He would agree. He started redesigning the HP package a couple of years ago. Most of the stuff in my document comes from his.
It was written and it evolved at a time kind of before we'd been doing Go for very long. So you can see there's in the standard library, there are lots of examples of things that really don't look very Go-like at all. And I think there's probably just stuff like that going around, isn't there, as well?
I think this is a good thing for beginners, too, to realize that even these people they look up to as amazing developers still look back on things they created and say, this needs improvement. Like it could be improved drastically now that I know more.
And it's just in use by maybe millions of people, certainly hundreds of thousands of people. using these things, and yet they still feel like that. I think that is quite a good lesson, because it's sort of, if software is never really finished, is it? That must be quite encouraging for a junior developer to hear, I would hope.
Yeah, there's no hope. You're going to feel awful about the things you write in perpetuity. Yeah. I'd say so.